are often called poly. That's the joke. Okay, so again, work on these pages to review quadrilaterals a little bit. We're gonna skip a bunch of pages actually, and go all the way to 50. Okay, go to page 50. That's polygons right there. Page 50. Have a few highlighters ready to go. Just so you know, polygons embraces all the shapes we've already done. It works for triangles, it works for quadrilaterals. So poly simply means many, right? So think of it as many sides / angles. Remember polynomials? I don't know if you remember that in grade 9. Yeah, many terms, nomials, many terms. So the same thing here. So polygon is a closed shape with the same number of sides and angles. One more time. I'm going to kind of just brush over this because we're only ever going to get convex polygons. But there's something, there's a convex polygon and then there's concave polygons, and they cave in. Think of it that way. A concave would just cave in. Let's just skip over that. That's not as important. This is important right here on page 50 if you're still looking. Let me just get this lined up here with my notes. How do you know a polygon is regular? This is the check you have to pass to be regular. All angles are congruent and all sides are congruent. That's the test you must pass to be called a regular polygon. I would add this to my study sheet. That's, in my opinion, they may ask you about this. How do you know this is or isn't a regular polygon? If you don't meet the criteria, you go into the irregular polygon category. Okay? So irregular could have some angles that are congruent, right? Some sides are congruent. So if you can't say all, you're in the irregular camp. That is the best way to look at it. Okay? And by some, I mean it could also be none. Obviously, if none are equal, then you're immediately in the irregular camp. Okay? So watch this one. You've got, let me just make sure I have the right version here. This would be an equilateral triangle. How do you know this is regular? Well, all three sides are the same. And what do we know about the angles of an equilateral? They're always 60, right? So it has two check marks, basically. Two check marks. All angles are the same, all sides are the same. A square would be considered a regular polygon because all four sides are the same. And what do all corners measure? The angles, they're all 90. Okay? So check, check. What about a rectangle? Would that be considered a regular? Let's see. All four angles are the same. Okay? All angles are congruent, check. But are all the sides the same? No. All sides congruent, sorry, it's kind of, it fails, right? It fails that test, so boom, it's not regular. An isosceles triangle up here, not regular, because it only has two angles that are the same, two sides that are the same. This one is obviously not, this one is obviously not. So anything that has not everything the same is irregular. I think that's all I'm gonna say to it. That's about it. But they can test it in weird ways. Okay, they can ask you this in interesting ways, but just remember this. Just remember that and you're safe. Okay, all angles are the same, all sides are the same. Let's keep going. It's 10 o'clock, I gotta hurry. That's what the beep beeps are, right? Okay, properties. All polygons have interior and exterior angles. Interior and exterior angles are supplementary. They have a sum of 180 degrees. Please highlight that. And here's how you find your exterior angles. I think we're all familiar with interior angles. Interior angles would be the ones that are inside the shape. So just go ahead all around and just put a capital I. Each of them has a measure. If it would be a regular, they are all the same. Okay. Then this is how you do the exterior. Watch this carefully. Pick any side around the shape. So let's say you want to pick that side. Just extend it here. Just go straight. Just follow the path of that side. There you have it. There's your exterior angle. And I'm going to go all around the shape. If you follow this side, just keep going that same path. There you have your second exterior angle. Continue that same side length. This is your third exterior. And keep going. There's only one exterior and one interior in every corner. Question or note. I could have gone around the other way and extended it this way, for example, like pick this side and extended it this way and have my exterior angle there. That is a possibility. It's not wrong, but there's only one per corner. Okay? So what I want you to note here is that, what do you think? Can you see that they're always going to add up to 180? This one is probably easiest to see here. There's a straight line right there. So exterior angle plus interior angle is always going to be 180 degrees, always. If you could have on your study sheet a little shape like this, and just label one of the I and the E's and one of the corners, and then have this next to it, it's probably going to help you out a lot. Okay. Another note. Okay. N is equal to number of sides. Always. When you talk in polygon, N will be the number of sides for us. How many sides does this polygon have? 1. Oh, I always put a check mark where I start counting. 1, 2, 3, 4, 5. N is equal to 5 sides. How many interior angles do you have? How many? 1, 2, 3, 4, 5. 5. Exterior angles, how many do you think? Count the exterior. 1, 2, 3, 4, 5. So, what happened? Okay. So the number of sides equals the number of interior angles equals the number of exterior angles in a polygon. That's very important. Another important property is this one right here. This is very cool. What do you consider cool, Mr. Dirksen? Anyways, sum of exterior angles is always 360. regardless of regular or irregular, regardless of the number of sides. That is pretty cool. So you could have a 99-sided polygon and you go and add up every single exterior angle, 99 by the way, it would always add up to 360. Like it doesn't matter how many, it's always 360. Okay? A quick example here. If this is your equilateral triangle, if this is 60, this is 60, and this is 60, how many exterior angles will this thing have? Let's see. Pick one here. There's one there. There's one there. And there's one here. What will each of the exterior angles add up to? If this is 60, then this must be 120, correct? This is 120, and this is 120. 3 times 120 is 360 degrees. So it's just a small, just one sample, but I think you just have to trust me on that one. That's what it is. Okay. Okay, let's look at the formulas real quick. Here they are. And you should be psyched about the formulas here. Is that still a thing? I don't know. Psyched. Got it? Get it? So my order is different than the formula sheet. But just grab your formula sheet. If you're ever needing to calculate anything regarding polygons, watch right here. It's right here. Sum of interior angles of polygons, measure of one interior angle. So every single formula is here, but not in the order that I gave you here. And what's so unique about them, look at every single formula. The only thing you need every single time is n. Every single time. N is the only thing you need to calculate any of those. And what is n? The number of sides, right there. So you don't have to have this on your study sheet. You're guaranteed that they will show up on your formula sheet at the back of the booklet. You rip this out. We will remind you the morning of. But this is going to be on there. If you're more comfortable and you have space, then maybe add this to your study sheet. Okay? So let's talk about where you find them. Okay? What does S do? S calculates the sum of interior angles. So all the interior angles in a polygon, if you want to know what they add up to, this is how you would do it. If you want to know just one interior angle, calculates a measure of each interior angle, you use this formula right here. And watch this. The sum, it takes the sum of all interior angles and divides it by the number of angles, basically, which is the same as the number of sides. Central angle, it's going to be 360 divided by n. Exterior angle, also 360 divided by n. And you're like, aren't they exactly the same? You are right, they're exactly the same. I'll show you where to find them in a bit. D, this has been very popular. D is what? Calculates the number of diagonals that can be drawn. That's how you calculate, that's what you use to calculate how many can be drawn. It gets pretty crazy. So don't draw them. Sometimes the province will say, you can draw them. Don't do it. If you get one wrong, you will lose all the marks there. Okay, so don't draw them. Let's do some calculating here using those formulas, okay? So come with me. This charger is going crazy there. Let's go to the bottom here. Label ICE. ICE, then calculate all of these things that we've just talked about for the following regular polygon. So we're going to end with this, most likely, but make sure you copy everything down here. If I ask you to label, which the province may do, one interior angle would be, you can do every single one if you'd like, but just make sure you put an arc where the interior angle is, and letter I in this case. Whatever letter you're instructed to use. There are 5 interior angles in this shape. Next, the C. It's called the central angle. Pay close attention to this one. It's not that hard, but you just need to make sure you do this right. Find the center of this thing and then make a pizza slice. That's what I always tell my students. Just from the center, pick a corner, right, that, and then go straight to, like along that side, make sure you have that one and connect it to that corner there. This angle here is what we call the central angle. How many central angles are there, you think? It's going to be one here, one here, one here, one here. So every side gets a central angle. We've just identified one central angle. Okay, I don't want to do everything because then it's going to cross out all the eyes. We don't want that. And then exterior angle. Pick any side of your choosing. You want the bottom here? Sure. Just extend it. Either side. It doesn't matter. Just extend it and put E there. Just please don't do this. Okay, I've had some students do this. That one doesn't follow either one of those, right? So you got to make sure it follows the trajectory of one of the sides to get that one right. So you've labeled an interior. In this case, we've labeled all interior angles. That's not wrong. And we've labeled one central angle. So now we're going to go ahead and calculate them. Okay, so let's go ahead and do that. The sum of, I'm not going to use the n, sorry. You can just go S is equal to, what is an n for this particular shape? Please put a check mark where you start counting. 1, 2, 3, 4, 5. 5 sides. So S calls for n minus 2 times 180. So to find the sum of all the interior angles, you simply go 5 minus 2 times 180, which is 3 times 180, which is 540 degrees. This is the sum of all the interior angles. The bigger the shape, the bigger this number is going to be. Like the more sides, the more degrees you're going to have. Okay? Next, let's find out the I. I'm following the order up there. I, the measure of just one of these, or the measure of each of these. I'm going to use the formula n minus 2 times 180 over n. N is 5, so it's just 5 minus 2 times 180. Don't forget this part right here. Over 5. That's the most common mistake that students forget, to divide by 5 in this case. If this had been a 7-sided, you just put in 7 wherever there's an n. 3 times 180 divided by 5. You can just multiply this out, but that would be 540 divided by 5. Notice that. Where did you get 540 from? You've seen it before, correct? It's all of them added up. So we're just going to split it evenly among 5 angles. So that's 108 degrees. So you've done sum of all, interior angle, like what each of them measures. Let's block this off here. What else are we going to do? Central angle. I'm going to continue down here. Central angle is 360 divided by n. And I'm just going to go sideways like this. That's 360 divided by 5. What is that? 72 degrees. The exterior angle, I'm going to cut this here, is 360 divided by n as well. That's 360 divided by 5. Guess what? It's going to be the same as the central angle. You notice something about the interior and the exterior? What do they add up to? 180. Remember I told you that they always add up to 180? So this is a way to verify, hey, they add up to 180, check, right? I'm doing something right here. We're almost done. Diagonals. This one is a bit trickier, but it's totally doable. What's n again? In this case, it's 5, right? So 5 times 5 minus 3 over 2. That's 5. Just clean it up. 5 times 5 minus 3 is 2. Divided by 2. If you see it, you could cancel out the 2's here. But if you don't, it's 10 divided by 2, which is 5. This one is not degrees. This one is actual diagonals. And I kind of ran out of space, but I'm going to show you what that means. Try a pentagon. It's not that hard. You just go like this, sideways, over. I'm saying it's not that hard, and it took me like 10 years to be able to do this, right? But if you were to use different colors, from here to here is 1. From here to here is 2. So those are the 2 you can do connecting to this corner here. I'm going to use blue. I'm going to move over to this one. You could draw one that way and one that way. That's 4, correct? You need one more. Anybody see it? From here, yeah, it's a star. There's one right there. So that is what this is calculating. How many diagonals you can draw, and the more sides you have, the crazier it gets. So please don't try to draw it. Just don't do it. The province will say, calculate or sketch the number of diagonals that can be drawn. And by the way, if you sketch it, they still want you to say how many though. Like if you sketch it and then you find out it's 5, they want you to say to figure that out. I'm gonna assign homework. Just page 52. Only one page, guys. Practicing what we've just done right now. Thank you. We'll see each other tomorrow. Is it Friday already tomorrow? Wow. Time flies.